Hello, gorgeous. We're going to mix an alkene reaction, alkyl reaction, and radical reactions. Okay, let's see if you can handle this. If you can, it's cool. We'll practice together. The more you do it, the more you see this, the easier it gets. Okay, all right, let's do this first. Let's see. For sure, we adding two more carbons. Did that? Okay, to add a carbon chain, you need an alkyne. This is how I see it is. All right, take a look real quick. Look at this guy right here. I'm gonna overlay the molecules that I can see it like this. Bam. See that? This guy come from an alkyne. This carbon is that carbon. This carbon is that carbon. So you can make this alkene from this alkyne. Why do we go this route? Because remember, there's only one reaction that allow you to extend the carbon chain. Is an alkylation of an alkyne. That one right there. Okay, you can. This is starting compound. This is the alkyl you want to add. So you can make this from an SN2 reaction like that. Okay. All right. So you want to do SN2 on here. We need a leaving group right there. Can you put a leaving group on this position? Yeah. So you have to go move the leaving group. For sure, you can add bromine on it. We have that bromination radical. Okay. And then you have to do elimination and addition reaction, and then move the bromine to the right. Okay, all right, let's start with the adding bromine onto the more substitute carbon first, the radical bromination. You get this, and then add a strong base. Any strong base work in here. Okay, there's only one type of E2 you can do. You can get this, and then we add a leaving group on the end like that. So this is anti-Markovnikov. Add this. You know? Lastly, not lastly, next one, we do an SN2 reaction. Take the nucleophile that look like this guy. Okay, do an SN2, you get to this, and make an alkyne, convert an alkyne to an alkene. You got options, either cis or trans alkene, right? Which one? Does it matter though? Not really, either one is fine. Okay, no cis and trans on this guy. Alright, that's part A. Let's move on to part B. Try to do it by yourself first, okay? Pause the video or whatever, like, and then you can check with me later. Don't just like look at how I do it and then cut, like follow it. It doesn't work. You have to be able to look at this, analyze it on your own, okay? Come up with a synthesis on your own first. Alright, so the product, look at the functional group of the product. This is carboxylic acid. There's only one reaction so far that allow you to make carboxylic acid. You know what that is? Is the ozonolysis of an alkyne. Okay, cut this bond right there. All right, you get carboxylic acid, and if you have do with the terminal alkyne, it's you get a carbon dioxide coming off. Okay, I'm gonna overlay this guy. Okay, so look like that. This carbon is the internal carbon like that, and we're losing the terminal carbon. Okay, through a carbon dioxide. All right, so you can make this the target molecule carboxylic acid from this alkyne. And this alkyne can be made, obviously, from an alkene. Remember that? Add two leaving groups. Okay? All right, let's do this. Add two leaving group onto it first. Elimination twice. If you're making the terminal alkyne, you have to quench. Okay? And then ozonolysis. Bam, that's a product. All right. Part C. Let's do part C. Let's see. We adding a carbon again, huh? We're adding one extra carbon, and you get carboxylic acid too. How do you make what functional group do you need to make a carboxylic acid? An alkyne. Okay, so you need an alkyne. Let's see. So I'm gonna come. So you have to need an alkyne like right there. Okay, to make from an alkyne. The starting compound is right here. 4 carbons. So you have to add this guy. Okay, you have this guy to this carbon. So you need a leaving group on that carbon. Is it SN2? Well, maybe even easier than the previous reaction. Okay, so first off, we start with this guy. You don't have to move the leaving group. It's already there for you. Nucleophilic attack on this SN2. You get this, and then ozonolysis. Bam, that's a product. Okay, all right. Part D. Let's see if you can handle this one. You know what the key step is? This is ozonolysis. Okay, I'm gonna put the number on both starting compound and the target molecule. 1, 2, 3, 4, 5. Okay, if I put 1 right here, do you know where's the 1 in this compound? You should guess it's that one. Okay, the one is sticking out, like that. It should be 1, 2, 3, 4, 5, 6. 2 and 6 used to be connected. Okay, so the double bond should be right here. Not an alkyne either, because if you have an alkyne, cut the alkyne, you would end up with a carboxylic acid. This is aldehyde. Okay, so you get this one. All right. And you need a double bond right here. To make a double bond, you need to do an elimination. To do elimination, you need a leaving group. Okay, and yes, you can put leaving group right there. That's bromination onto carbon 2. All right, let's start with the radical bromination right there. And then we need double bond inside the ring, Zizeb. Okay, so add a small base of your choice. Get this, and then ozonolysis. Ta-da! Not that difficult, huh? Okay, all right, let's try the actual exam question on the next video together.